So following on from the previous video, we were trying to work out the surface area from 1 to 2. So it really boils down to us trying to integrate this, it boils down to us trying to integrate this thing here. So we made our substitution. So we started out with working in terms of x, and then we made a substitution. Now we are working in terms of theta. Here we are integrating from 1 to 2, from 1 to 2. So this is in the x world, but now we are now entering the theta world. So rather than changing the limits of integration, we're just going to leave it as x equals 1, x equals 2. Later on, we're going to convert all the thetas back into x, and then we can integrate it from 1 to 2. Okay, so we started out with theta, with x. We made our substitution to theta. Later on, we're going to switch everything back into x, so we can integrate it from 1 to 2. Anyway, we got to this stage here in the previous video. We said that x to the power 4 is really tan squared theta. So now we've got to try and integrate this. Whenever you have a mixture of secant and tan, there's a lot going on here. So translate everything in terms of cos and sine. So for example, secant to the power 3 is 1 over cos to the power 3. And then you've got your divide. So this is your divide, and then tan squared is sine squared over cos squared theta. So turn everything into sine and cosine. So everything here is in terms of cosine and sine. So now when you divide by a fraction, that's the same as you multiplying by its reciprocal. So that's the same as you multiplying by its reciprocal. So that will then take us to here. And then now let me think. What now? Okay, so this thing here cancels out with this, and then you've got sine squared here. So that from here, that will then take you to here, and then this thing here is secant theta. This thing here is cosecant squared theta. So now we need to translate this block. So remember, picture this in your mind. We've seen this diagram before. If you create yourself a unit circle and then draw a tangent line right here, this length here is cotangent. This length here is cosecant. This length here is 1. So using Pythagoras, this squared equals this squared plus this squared. Well, you've seen this before. So now we can put this thing here into here. So that will then give us this thing here. So now multiply this out. This times this times this. That will then give us this. Okay. So now translate. Hang on. Now let me think. This thing here is 1 over cos. This thing here is cos squared over sine squared. So now you can see that. Well, let's visualize this as one block multiplying with another block. This thing here is really sine times sine. Well, you've got a block over here, so this will cancel out this. But then I'm going to move this block over to here. So that would be 1, and then you moving this over to here. That would be sine here, and then you've got your one block of cos and then one block of sine. Well, this whole thing here is this thing here. So now hang on. Now this thing here is cosecant. This thing here is cotangent. And then right from the start of the previous video, I said that you should know that when you differentiate cosecant of x, that equals minus cosecant x cot x. So now we've got this thing here, which is this thing here. So when you integrate it, it should be easy to integrate. It will be negative this thing here. Well, integrate this, it will give you this. And then we've seen this before. right from the start of the previous video, I said you should know how to integrate this because we've done it many times. So when you integrate this, it will give you this thing here. So integrating this will give you this. Integrating this will give you this. So so this whole thing here, if you integrate it, it will give you this. So now remember, we are currently working in terms of theta. We need to translate, because look, you've got theta here, you've got theta here, you've got theta here, but we are trying to integrate from x equals 1 x to x equals 2. So we need to turn everything back into x. So looking at the diagram that we created in the previous video, what is secant theta? Well, secant theta is this thing here. Secant theta is hypotenuse over adjacent. So it's really this square root thing divided by 1. So it's really this square root thing divided by 1. So so translating this block here will then give you this block here. What is tan theta? Well, tan theta is this thing here. Tan theta is x squared over 1, which is just x squared. So this block here becomes this. And then what is cosecant? Well, cosecant is this thing here, which is square root thing divided by x squared. Now everything up here, well, this is x equals 1 to x equals 2. Because everything's in terms of x now, we can just integrate it from 1 to 2. So integrating it from 1 to 2, let's put this into here. Oh, by the way, glancing at this, this thing here would never, to the power of 4 would never be a negative. And when you square something, it will never be a negative. So we don't really need the absolute here. We can just turn it into the normal bracket. Okay, well, we don't need the absolute here in our case. If you have to the power of 5, then you've got to think about it. Anyway, this thing here will never be negative, so we don't need the absolute here. So now let's put 2 into here. So that will be 2 to the power of 4. 2 to the power of 4 will not be 5. Hang on, 2 to the power of 4. Let me think. 2 to the power of 4. So that would be 16, 17. This should be 17. Hang on. This should be 17. So if you put this 2 into here, that will then give you this. Well, 2 to the power of 4 would be 16, plus 1, that would be 17. And then we've got to put this into here. That would be 4 here. And then put 2 into here. That will not be, this thing here would be 17. So this thing here should be 17. 17. And then let me think. Yep. So let me tidy this up. Oops. I'm going to leave this as an exercise for you. From here, if you put 1 into here and put 1 into here, that should give you the right answer. This here is wrong. Okay. So it's an exercise for you to do.